All right. Revolutions around an axis. Okay. This is what happens. Okay. So take this and revolve it 360 degrees around the x-axis here. If we revolve it around 360 degrees, we make like a solid semicircle type thing. Okay? That's like a hemisphere. You rotate it all the way around, it's a half of a sphere, basically. Okay? Do you get what we're after? Okay? So then what we're going to do is, what we're going to do is take a little line like this and wrap it around, and that makes a little disc. Okay, a little flat disc. Okay, and if we add up all our discs together, then we can figure out the volume of this object that we just rotated around. And you think, why in the heck would I ever want to know that? Well, guess what? Engineers do this. And actually, their computers do it for them, and they just punch things into their computer. But somebody has to design the computers for them to do it with. Okay? So, yes, this is fluid dynamics and things like that you'll be studying in engineering school for any of you who go to engineering school. Okay? So what we do is we got all these thin slices that we're going to just rotate around. So what it does is makes a circle, a filled-in circle. Okay? How do you find the area of a circle? Pi r squared. Okay? So imagine a whole bunch of circles stacked on top of each other of different sizes. And so then, because they're different sizes, we use the equation of where we're at the time. So we're going to integrate pi r squared of where we are on the graph at the time. Where we are on the graph at the time comes from our equation. Okay? So we're going to take this because the height of this is this. Okay? So at 2, our height of this will be the square root of 5. At 1, it'll be the square root of 8, and so on. So that's the radius of the circle at that time. Right here, the square root of 8 will be the radius. At 2, the radius will be the square root of 5. At 3, the radius will be 0. Okay, so that's where we'll end. Okay, so what we do is we go pi r squared. Well, if you take this and you square it, when you square a square root, you get what's underneath. Okay, so we set up our integral from 0 to 3 of pi r squared, and we slip that pi on the outside because we want to put it in terms of pi. And we take this and throw it into our graphing calculator and let our graphing calculator do the math for us. Okay, now if this is on the AP test and it's on the non-calculator section, you're going to actually have to do it yourself. When you go 9x minus 1/3 x cubed from 0 to 3, plug in the 3, plug in the 0, and solve. Okay? But if you're on the calculator version, you just plug it into your graphing calculator. It spits out 18, and you throw the pi that's out in front behind it, and you get 18 pi. We good with that? Okay. So now let's take this one. Okay, this time instead of wrapping it around the x-axis, we're going to wrap it around the y-axis. Okay, so our discs are going to go this way. Our circles are going to go this way, and they're going to go around. So you're going to make circles like that. Okay? Now, the problem with going around the y-axis instead of the x-axis is this. That equation is solved in terms of y, and we need it solved in terms of x if we're going around the y-axis. So what do I do? Well, this is actually really, really simple. We're going to square both sides. So y squared equals 9 minus x squared. We're going to add x squared to each side. We're going to subtract y squared from each side. And we're going to take the square root of each side. So what basically happened? They just basically switched around in this equation. Now, is it going to happen that way every time? No. But these, they just basically switched around. Okay? So, to give the exact volume, we're going to go from, on this one, we went from 0 to 3 along the x-axis. So here, we're going from 0 to 2 on the y-axis. So we're going to integrate, throw the pi on the outside, 0 to 2 of pi r squared, so 9 minus y squared, the square root of it squared, which then basically gets rid of that dy. So if we throw it in our graphing calculator, I'll have to then, because the graphing calculator doesn't use y's, it uses x's on. So we go second, no, not second, just straight math, number 9, and then 0, and then 2, and then 9 minus x squared dx, enter. We get that. Now, the Khan Academy doesn't like that, so we go math, change it into a fraction, please. And it does. So it's 46 pi over 3 is our answer. Okay? Get the gist of it?
Yeah.
Okay, let's do a couple more. Okay, we're going to rotate this around the x-axis. So our discs are going to be this way. Okay? Discs are going to be this way. So we're just going to integrate from what to what?
0 to pi.
0 to pi. Because pi here, 0 here. Okay? Of sine x. And we're going to square it because pi r squared and put the pi out front. Dx. We good? 0 to pi of sine x squared with pi on the outside. Okay, this one, not so easy. Not like the last problem. Where are we going to go around here? Well, we're going to go around the y-axis this way. So what do we have to do with this sucker? Oh, you are so smart, Miles. We're going to natural log both sides. Okay? So then the ln of y equals x. Okay? So we're going to integrate from what to what? 2 to 5. That's a small number. That's a 2. Sorry. 2 to 5 of the ln of y squared dy with a pi out front.
Why did we square it again?
Pi r squared
Right.
is the area of a circle. Okay? You guys are good. Okay. So that's it for before lunch. After lunch, we'll do if it's not the x-axis or y-axis, because it's super easy, x-axis or y-axis. This shouldn't take you too long. Do this first, and then go back to some of your other stuff that you had problems with.
Okay.
Please.